Hello everyone. So today we are going to try this problem game with marbles hard version. The difference between hard version and easy version is just about the constant of n. Yeah. So before looking into the video solution, you can pause the video, go to the problem, try it once, and after that you can look into this video. Okay. I hope you have tried this problem at least once. So let's look into the problem statement directly. It is given that there are two players, Alice and Bob, and both the players have n different colors taken. And yeah, that is Alice has A1 color of A1 marbles of color 1, A2 marbles of color 2. Similarly, AN marbles of color n, and so on. Similarly, Bob has B1 marbles of color 1, B2 marbles of color 2, BN marble of color n, so on. And it is also given that AI and BI lies in the range between 1 to 1 in 9. Now, they both play a game. So in this game, what happens? That Alice plays first, then it's a Bob turn, and they play, and after that they play alternatively. What actually happens that suppose it's any player turn, so he will choose the player. Okay, now the player will choose a color eye such that both the players have at least one marble of that color, and after that the player discard one marble of color eye from himself and discard all marbles of that color from the other player. For example, let's understand this by example here. Okay, just a second. Let's take the first example here. Suppose we are having three colors, and let's take the input for Alice, and let's take the input for Bob. So Alice has four marbles of color 1, and Bob has one marble of color 1. Similarly, Alice has two marbles of color 2, and Bob has two marbles of color 2. Similarly, Alice has one marble of color 1 and four marbles of color 3. Bob has four marbles of color 3. Now, let's say Alice goes first. Let's say Alice takes color 1, marble of color 1. So he will discard one marble from his and discard all marbles from Bob. So after Alice turn, it would look like something 3, 0, 2, 2, 1, 4. Now it's Bob turn. Let's say Bob chooses color 2. So he will discard one marble of color 2 from himself and discard all marbles of color 2 from Alice. So it would look like 1, 0, 1, 4. Now it's Alice turn. Then Alice would choose, obviously Alice cannot choose this 1 and 2 because in the color 1 Bob has 0 color, in the color 2 Alice has 0 color. It is given that if any player chooses color I, then both the players should have at least one marble of that color. So Alice is forced to choose color 3. In that case, Alice would discard one marble of color 3 from himself and all marbles from Bob. So yeah, 1 minus 1, 0, and discarding all marbles of color 3 from Bob, it would look like 0. And after that, it is given that let's say after completion of game, Alice has A total marbles, and Bob has B total marbles. Then Alice would maximize A minus B. Right, Alice's intention is to maximize A minus B, and Bob's intention is to minimize A minus B. If both the players play optimally, we need to print the value of A minus B. In that case, in this scenario, you can see total number of colors of Alice is 3 and total number of colors of Bob is 1. So in this case, A minus B is 2. Now, let's take another scenario. 4, 1, 2, 2, 1, 4. Okay, let's take this scenario. Okay. Okay. In this scenario, um, let's say Alice chooses color 1, so it would finally become 3, 0, 2, 2, 1, 4. Now let's say Bob chooses color 3, it would become 3, 2, 2, 1. It would become 0 and it would become 3. Now, now it's Alice turn. Again, Alice would choose color 2. It would become 3, 1, 0, 0, 0, 3. So here A is 4 and B is 3. So in this case, answer is A minus B is 1. If both players play optimally, answer is 1. Right? Earlier, earlier, what actually happened? Actually, Bob played for color 2, but in this case, what happened? Bob played for color 3. So in this case, Bob is getting 1. So Bob what? Obviously, Bob will play for color 3 because it is minimizing our answer. Bob's intention are to minimize the value of A minus B. So let's see what is the total answer. Yeah, total answer is 1. So yeah, our answer matches with the output. Now, how can we solve this problem? Okay, let's see. Let's take one of the example to understand. Okay, suppose right. Actually, we need to calculate the value of A minus B. What is the intention of Alice? Alice's intention is to maximize the value of A minus B, right? So what he can do is that either what he can do is that either he can he can write in your mind it will be coming that either Alice can maximize the value of A or minimize the value of B. Means either he can increase the value of marbles of his turn, right? He can increase the marbles of A or he can decrease the value of B. But let's see, but let me give you another optimal way. Suppose let's say we are having yeah, let's take this example. Okay, suppose Alice is having colors of this and Bob is having. Okay, let's play this, right? Let's play game in this scenario. It's Alice turn, so let's take the scenario. Alice remove the color 1 and yeah, and it would become 0. Now it's Bob turn. Bob will obviously make it 199 and it will be 0. So what's the answer in this case? Answer in this case is minus 198, right? Okay, let's take another scenario. Okay, let's solve it by second way. Um, let's remove here from this. It will become 499, 0. Again, it's Bob turn. Bob will play by it would be 299 and it would be 0. What is the difference? What is the now value here? It's 400 minus 20, that is 200. So what Alice will do? Alice won't play this. Alice will play first this because both the players are playing optimally. So Alice need to maximize the value. And if Alice plays this, Bob is forced to play this, right? Yeah. So actually, what Alice will do? If you see carefully, what Alice will do? Alice will okay, it was 300 and it was 200. See, what Alice will actually do is that Alice will um, right. Suppose we are differentiating AI minus BI, right? Suppose if we are choosing, right. So what actually would be happening in Alice turn? What actually would be happening is that Alice would be having marbles. Alice would be left with the marbles AI minus 1, right? And he would be decreasing the marbles of Bob by BI. So what overall effect he would be having? He would be having overall effect of AI plus BI minus 1 because he is getting plus of this means he's actually getting this much marbles and is removing this much marbles from Bob. I hope you got this. He's in this case, right? In this case, he was getting 499 marbles and he was removing 200 marbles. So he was having advantage of 699, right? But in this case, he was getting 1 from this and he was removing 300. So he was getting, in this case, 301 marbles. So which is a better, which is more optimal? if Alice getting is a profit of 699 and Alice is getting profit of 301, this is better. Obviously, getting a profit of 699 is more profitable than 301, right? And same goes with the Bob. When Bob is playing, yeah, and if he's removing in color, if he's removing right uh, BI color, then he would be having BI minus one color, marbles left, and he would be removing AI marbles from Alice. So he would be getting a profit of BI minus BI minus one left marbles and AI marbles getting removed from the Alice. So obviously Bob will choose that marble in which this sum is maximum. Similarly, in Alice's turn, he would choose this marble in which this value is maximum. Right. Minus 1 is constant for both the cases, right? In both the cases, the final output is AI plus BI minus 1. Right. So let's neglect it. Let's take it as AI plus BI. So anyhow, if anyhow we maintain in that if we maintain set of priority queue, okay, if we maintain set of priority queue of AI plus BI, then we can solve this problem, I guess. Because in Aliston, he would choose that color which is having the maximum value of this. In the Bob turn, Bob will choose that color which is having the maximum of this. Got it? And after finishing the game, right? After finishing the game, they would just differentiate. They would just count the total number of colors of Alice marbles and count the total number of marbles of B, right? Bob. After that, the answer would be A minus B. Okay, let's understand this. Let's understand this by an example. Let's take the second example, that is 1, 20, 1, 20, and yeah, 1, 0, 0, 15, 10, 20. Okay, here sum is 40, here sum is 11, here sum is 35, here sum is 101. Now it's Alice turn, right? Now it's Alice turn. So Alice would obviously choose this one, right? Alice would choose this one. So what finally it would become? It would become 0 and 0. Now it's Bob turn. Bob will choose obviously this one, maximum value, this one, right? So what would it eventually become? This one would be 19 and this one would be 0. Now again it's Alice turn. So Alice would choose this color. So it would eventually become, yeah, it would be 19 and it would be 0. Again, it's Bob. So Bob is forced to choose this one. It would become 9, it would become 0. So what's the final Alice? What's the final number of marbles Alice having? 9. What's the final number of Bob having? That is 28. What is A minus B? A minus B is minus 9. Okay, what's the output here? Minus 9. It means that our approach is correct. Okay, let's look into the code of it. I hope you understood the problem statement and my solution approach. If you haven't, uh, rewatch the video, right? Okay, I hope you got the solution approach. You can try pausing the video here. You can try writing the code yourself. Try it once. If you're not able to write the code by yourself, you can just attempt. You can just look into the code after this, after um, erasing the video. Okay, you can look into the code here. So yeah, first of all, I took then I took the vectors. Now I'm using set. Let me explain you what I'm doing. Actually, I'm using set and I'm inserting the numbers as a pair, right? That is, the first is sum of AI plus BI negative comma AI. Why negative? Because set automatically stores the element in sorted order and I for storing the index of that, right? Now, I'm also calculating turn, right? I'm also calculating the turn that whose turn it is. If turn modulo is 0, if turn mod, okay, you can do it as turn is equal to 1 and turn is equal to 0. You can do this also. If turn is 0 means it's Alice turn, if turn is 1 means it's Bob turn. Now, so I'm iterating over the set. Why I'm iterating over the set? Because set will automatically store the maximum element first, right? maximum value of AI plus AI and BI first. And I'm also storing the index, right? So obviously, when I'm iterating on the set from beginning, automatically the first occurrence would be the maximum value of AI and BI. So in case of Alice then he would decrease the value of that index by one, decrease the number of marbles of that color. That color number is obviously I, that is v dot second, by one, and it will and he will automatically make the number of marbles of that color in the b would zero. After playing with the Alice turn, it will be turn of Bob. Similarly, when it's Bob turn, he would decrease the number of that color by one, and in the and number of marbles of that color in the Alice would be zero. And after that, I'm calculating the total sum of marbles of Alice and total sum of marbles of Bob. And after that, I'm just subtracting it and then printing the answer. Let's submit this code. Let's submit this code. Okay, yeah. This problem was E2. Okay, submit. Yeah, it's accepted. Right. I hope you enjoyed the solution, and I hope you got. Okay, I hope you learned something new from the solution. You can look into the submission at my ID is Levan. You can make me friend on Code Forces, and then you can look into the solution. Thank you.